Imagine your email inbox as a battlefield between safe messages and spam. Each email is represented as a point on this chart. On the horizontal axis, we might have something like the number of suspicious keywords, like free. On the vertical axis, maybe the number of links inside the email. Now, blue points are normal emails and red points are spam. As you can see, spam emails tend to cluster in a different region. They usually contain more free words, more links, more suspicious signals. So naturally, we want a way to separate these two groups. This is where logistic regression comes in. Our goal is to classify emails into two categories. 0 means the email is not spam, and 1 means it is spam. But computers don't understand emails the way we do. So instead of reading full sentences, we break each email down into measurable features. For example, we might count how many times the word free appears, how many links are included, and how long the email is. These features help us capture patterns. Let's take an example. If an email contains the word free 3 times, has 2 links, and is about 100 words long, we can represent it as a set of numbers. Free equals 3, links equals 2, and length equals 100. So instead of working with text, we've transformed the email into numerical data. The goal is simple. We want to classify emails into two categories. This is where logistic regression comes in. It draws a line called the decision boundary to divide the space into two regions. On one side, not spam. On the other side, spam. So now, when a new email arrives, we simply check which side of the line it falls on. But logistic regression doesn't just give a yes or no answer. Instead, it thinks in probabilities. Every email gets a score, and that score is converted into a probability between 0 and 1. Low score? Close to 0, likely not spam. High score? Close to 1, very likely spam. Finally, we choose a threshold, usually 0.5. If the probability is above 0.5, spam. If it's below, not spam. And that's how logistic regression turns messy real-world data into a clear, intelligent decision. These weights show how each feature influences the prediction. A positive weight, like free equals plus 1.5, means it pushes the email toward being spam, and since it's large, it's a strong signal. Links equals plus 1.0 also increases the chance of spam, but not as strongly. A negative weight, like length equals minus 0.01, means longer emails are slightly less likely to be spam. So overall, the model combines these effects to decide. More free and links, more likely spam. Longer email, slightly more likely not spam. This is why logistic regression is powerful. You can understand why it makes a decision. This piece of code builds a very simple spam detection system using machine learning. We start by importing two tools. The first one, CountVectorizer, is responsible for converting text into numbers. The second one, Logistic Regression, is the model that will learn how to distinguish spam from normal emails. Next, we prepare a small dataset. We have a few example emails, some clearly spam, like free money now or win free prize, and some normal ones like meeting scheduled tomorrow or project discussion notes. Along with these emails, we provide labels. 1 means spam, and 0 means not spam. Now comes a crucial step. Computers don't understand text directly, so we use CountVectorizer to transform each email into a numerical representation. It does this by building a vocabulary of all unique words and then counting how many times each word appears in each email. So each sentence becomes a vector of numbers instead of words. Once the text is converted into numbers, we train the model. Logistic regression looks at these word counts and learns patterns. For example, it may learn that words like free, win, and prize are strong indicators of spam, while words like meeting or project suggest a normal email. After training, we test the model with a new email, free prize now. We convert this new email into the same numerical format using the same vocabulary, ensuring consistency. Then the model evaluates this input and calculates a probability. It gives us a number between 0 and 1, representing how likely the email is to be spam. Finally, the model makes a decision. If the probability is high, typically above 0.5, it classifies the email as spam. Otherwise, it labels it as not spam. After I clicked run, the result come out.